In this video, let's look at increases in standard of living and capital deepening per person. To increase standard of living, we need even small changes in the rate of growth. When this is sustained and compounded over a long period of time, the standard of living goes up in the long term and the short term. The formula we will use here is GDP at starting date. With that, we multiply the thing in brackets 1 plus growth rate of GDP to the power number of years, and we get GDP at the end period. Now this 1 plus growth rate of GDP to the power number of years, I can use either this function in the calculator or this function in the calculator. Depends on what your calculator is showing you. I have 4 different growth rates. I have the original value or the GDP at the starting date, which is $100, and I have 3 different time periods. Now let's look at this 1% growth rate. The original value is equal to 100, and look at the value after 10 years. This will be equal to 100 times 1 plus growth rate. The growth rate is 0.1% is 0.1 to the power 10, and you get 110 as the final value. Now I have 100 as the starting value, so 128 is equal to 100 times the growth rate, remember, is still 1%, 1 plus 0.01 to the power 25. This one, 100 is still the starting value. I am multiplying 1 plus the growth rate, 1 plus 0.01 to the power 50. Let's look at this 5% growth rate. Again, I have this initial value as 100 and looking at time period of 25 years. How do you get this 339 here? GDP at starting value is 100 times growth rate is 5%. That is 0.05 to the power number of years is 25. This is how we do it. I can look at this 8% here. By now, you'd be a pro at this growth rate calculations. This is the initial value, this is the growth rate given to us, and this 50 is the number of years. So this is the magic of compounding. Even if you start at 1%, if you compound this, the value goes up. Basically, the standard of living is increasing over time. Alright, so in this example, we have South Korea that started with a gross domestic product of 1.67 trillion, and the growth rate is 2.8%. And we are looking at the year-end amount. So 1.67 is the starting value. Then we have 1 plus 0.028. It should be the growth rate is equal to 2.8%. And this is going to be equal to 1.72. If this calculation just messes you up, we can do something else. instead of writing 1.72 here, like they're like taking this starting value over here, we can do something else for year 2. I'm trying to find out the ending value for South Korean economy after 2 years. They started with 1.67. They have a growth rate of 2.8%. So this is what I have here. And just remember, 2.8% is equal to 2.8 over 100. So I can write this as 0.028. All right, coming back to our initial problem. Year 2, my initial value is 1.67. I will multiply times 1 plus the growth rate, and we are looking at 2 years. So that's why I'm going to square it, and I will find I'm just writing down the result here. Please check the math. This is equal to 1.67. This is how you do it. If you are doing it, say for a period of 100 years, the growth rate remaining the same, everything else remaining the same here, what will change is this one. So everything changes if you change the number of years, if you change the initial growth rate, and definitely the initial value. So I would say the standard of living depends on 3 things here. And what are the 3 things that we learned about? The standard of living depends on what is the initial value we started with. Number 2, it depends on the growth rate. Number 3, this depends on the number of years. Number of years is also very crucial to look at. We can compare our standard of living 50 years back right now and 50 years from now, and we can think of the magic of compound growth. Okay, now we look at the components of economic growth. We need saving and investment in physical capital so that we can have economic growth. Examples of physical capital, we have infrastructure. More physical capital means more output. By more output, we mean more real gross domestic product. Remember, when real gross domestic product increases, economic growth occurs. So we have examples of infrastructure. We need increases in quantity as well as increases in quality. The second component of economic growth is expansion of human capital. Example of that, we have skills, education, we have all kinds of knowledge. Also, we can just add some in-job training here. This will make the workers productive. Number 3, we have discovery of new technology. Herein comes the concepts of invention and innovation. All these 3 added up or taken individually leads to economic growth. Now let's look at the definition of capital deepening. So by that I mean, I can just say more resources to workers. And what are examples of resources? It can be physical capital or it can be human capital. One example is physical capital, another example is human capital per worker. More equipments, more machinery, more education, more skills. If we do that, we are going to have increased output and increased real gross domestic product. Okay. Look into this graph here. On the horizontal axis, we have capital per hour of labor. On the vertical axis, we have real gross domestic product per hour of labor. This one is an input. This one is output. And this PC0, this is the productivity curve. If we increase capital from 0 to 80 to 180, what do we see? So I have a cause here and I have an effect here. So the cause is gonna be increase in physical capital. So over here we are looking at increase in physical capital per hour of labor. And if we look at the effect, we are looking at increase in real gross domestic product. Definitely increase in physical capital will lead to increase in real gross domestic product. But we are moving along this productivity curve. Now, what happens if we increase human capital and if we increase technology? So in this curve, I still have capital per hour of labor, but I have different causes here. I have two different causes. Number one, we can have increase in human capital per hour of labor. Number two, we have increase in new technology, and this is kind of increase real GDP per hour of labor. And the way it is doing here is this is shifting the productivity curve upwards, and this is increasing the real GDP per hour of labor even more. So I'm just going to write down the effect here. The effect is increase in real gross domestic product per hour of labor. That's quite straightforward. So this one is just showing me the increase in human capital. Okay, so we have a lot of people with high school degree and the number of people with college degree, this is really going up. That means we have some kind of rise in human capital in the US over time. And this is showing me the increase in physical capital. This can be new infrastructure, new plants, new equipments. So the physical capital has also increased over time. So this is basically all in the slide. Thank you so much.